could actually write a radical by using rational exponents. And that's why at the beginning of this chapter, we did properties of exponents, because we're going to write radicals with exponents, and then we're going to use the properties of exponents to simplify. Okay. So by rational exponents, we mean exponents that are fractions. Right? Rational number is a number that can be written as a fraction. So for our purposes here, rational exponents mean when you've got an exponent, which is a fraction. So that's just another way to write a radical. So the square root of 4 can be written as 4 to the 1/2. The third root of 27 can be written as 27 to the 1/3. How do you think I would write a fourth root? To the 1/4. How about a fifth root? To the 1/5, right? That's the pattern, basically. Now, if you wanted to convince yourself that this is true, you could just put it in the calculator. Use your calculator and go, 4, instead of doing the square root of 4, which we all know is 2, do 4 raised to the 1/2. And you get 2. So 4 to the 1/2, same thing as square root of 4. Or try 27 to the 1/3. Enter. 3. All right. So at the very beginning of this section, we basically use that knowledge to rewrite these as radicals and then simplify as radicals. So for example, 216 to the 1/3 as a radical is what? Raising to the 1/3 power would be the same thing as cubed root. And again, at that point, if you don't recognize right away which number cubed equals 216, you could always put it in the calculator, right? You have, in the calculator, where do you find cubed root? Math, 4, right? And so you put in your 216, and you got it. There's your 6. Of course, you could have said to the 1/3 power. Okay, how can I rewrite this multiplication using radicals? How do I rewrite 7 to the 1/2? The square root of 7 times the square root of 7. And what is the square root of 7 times the square root of 7? 7, right? That thing has to be just like automatic, because if we make these a lot, where you multiply a radical times itself, it just means you get rid of the radical, or the square root anyways. But remember the property of exponents. When you multiply with the same base and they have exponents, what's the operation that you use to simplify the exponents? Right? Remember it was x to the a plus, no, it was a to the n times a to the m. What did you do with the exponents? You add them up, right? So what would happen here if I add up these exponents? I'm going to get 7 to the 1/2 plus 1/2, which is 7. So you can actually do this operation, just use the properties of exponents, now that you have exponents. I have a feeling like 90% of this today you're going to find very easy. And even the other part is probably not that hard. I'm not going to give you that problem on a test, okay, or like it. This is just like introduction kind of thing. How do I rewrite this one? okay, the fourth root of 5 times the fourth root of 125. But now, remember, we have properties of radicals that says, a product property says if you have the product of radicals, how do you simplify it? The product of radicals equals one radical of the product, right? Put those together in the same radical. So that makes it the fourth root of 625. Okay, now how do I do a fourth root in the calculator? Okay, so where would you go in the math menu? Math 5, right? Okay, now I want to do the fourth root. How do I make that into a fourth root? Okay, you can scroll over the A and S there and put a 4, and then put the 625 inside, and you get 5. You know, to me, it probably is easier just going 625 raised to the 1/4 than having to scroll over the top of that. It is the same thing. So when you get comfortable with the rational exponent, sometimes that's the easier way to simplify. Okay, now another thing, what that points out, I mean, we have a property of exponents too that says a times b to the n equals a to the n times b to the n. Well, we're kind of using the reverse of that property here. I could put those both together, 5 times 125, and all of that is raised to the 1/4. I mean, that is really the product property that we use with radicals. 625 to the 1/4, which is 5. Okay, how do we rewrite 64 to the 1/2? The square root of 64, right? Which is 8. Okay, how do I rewrite the last one? The square root of 11 times the square root of 11 equals 11. Again, you could have just added the exponents, and that would have been 11 to the first power. You know, use the properties of exponents. Okay, now every rational exponent will not be a fraction that has 1 in the numerator, right? They will be more complicated than that. Things like to the 2/3 power, right? Here I've got 8 to the 2/3 power, which I'm rewriting it twice, right? The first time I'm going to say, okay, that's like saying 8 to the 1/3 squared, right? Because what is properties of exponents wise? What do you do when you raise a power to a power? How do you simplify it? So multiply, right? So 1/3 to the 2 power, if you multiply those together, you get 2/3. So I've just split it up in a way. Now, the 8 to the 1/3, we know what that is. That's the cube root of 8. And then you have to square it. So this would be what we call the rational or the exponential form, right? This is the radical form. This is not necessary to show. Right? Just we need to know how do we rewrite this exponential form as a radical. Now, if I would have, instead of doing it the way that I did, if I would have flipped the 2 and the 1/3, right, it's still 1/3 times 2 is 2/3, so it still works. But now it's the cubed root of 8 squared, which is another equivalent, perfectly valid way to write this exponential in radical form. Now, in both of them, what doesn't change? What doesn't change between these two radicals? The index is the same, right? The index is always going to be 3. Okay, now where did the index come from? Over here. It was the denominator, right? So it's always you're going to take the denominator and make that the index. And then the 2 in the numerator, that's either outside the whole radical or it could be inside. It doesn't matter. They equal the same thing. I mean, you could do this in your head if you want. What's the cube root of 8? What's 2 squared? 4. Okay, try this one. What is 8 squared? What's the cube root of 64? 4. In either way, it's the same thing, right? So the basic pattern is this. If you get something raised to a fraction as the exponent, then you put the denominator as the index, right? And then you take the numerator, and that becomes the power that this is being raised to, either inside or outside the radical. I think if you just keep straight that the denominator is the index, then you can't go wrong after that. Just get that index correct. Because in the end, you could guess, oh, does it go there or does it go there? Guess what? It goes either one. So get the index in the right spot. So we'll do a couple. This is, in fact, if you look at the SOLs and the essential skills and all that, this is like the only thing that is directly addressed in this section, is converting from one form to the other. Now, there are things that we'll use, like in the next lesson, we solve equations. And you kind of need to know how to do this stuff when you solve the equations. Okay, how can I convert this x to the 3/7 into a radical? What will be the index of the radical? 7, right? So that is the 7th root, and then what goes inside? X to the 3rd. That's a bad 3. I'll try that again. X to the 3rd. And like I said, you could have also written it like this. The 3rd root of x raised to the 7th. Either one is fine. Okay, how about this one? What's different about this one? It's a decimal. It's not a fraction. But is it a rational number? Decimals are rational numbers as long as they terminate. They would be rational numbers. And this is clearly a rational number. So if we want to use these rules, right, we need to turn that into a fraction. Right? What fraction does negative 3.5 equal? Okay, 7 halves. Now, if you're not great with fractions, right, you could do that in the calculator, right? You just go negative 7 divided, oh, sorry, that was wrong. Put in negative 3.5, hit enter, and then do math, enter, enter. And it turns that into a fraction, negative 7 halves. So we want to write this, y to the negative 7 halves. Okay, now we can't leave a negative exponent. How do we get rid of negative exponents? Say again? Put it in the denominator, right? If it's a negative exponent in the numerator, then it's a positive exponent in the denominator. Okay, now turn that denominator into a radical. What will be the index? 2. So should I write a 2 in there? No, we assume it. Okay, and what goes inside the radical? Y to the 7th. So remember, when you get the negative exponents, we never leave it with a negative exponent. You need to flip it to the other side of the fraction, turn it positive. Okay, let's try another one, if we're ready. Okay, now we're going to go the other direction. We're starting with radicals, and we're going to turn them into exponentials. Okay, what is this? The square root of a to the 5th. Right? It's a to the, what is the denominator? Denominator is 2, right? Because it's a square root. There's a little invisible 2 right there. And then the 5 is in the numerator. How about the 5th root of b raised to the 3rd power? What is the denominator? What is the denominator? 5. Right? The index is the denominator. And what is the numerator? 3. Piece of cake. Good? Okay. Okay, so try to do the same thing with those two. One of them is going from the rational exponent to the radical. The other one's going from the radical to the rational exponent. Remember what we did first when we had the decimal. What did we do first? Turn it into a fraction, okay? Everything we're doing now depends on us having fractions for exponents. So turn a decimal into a fraction. What fraction does 0.2 equal? 1/5, right? I mean, if you don't, right, if you don't know, other than, using the calculator to do it, just remember that's 2/10. It's the tenths place, 2/10, 1/5. Okay, how about this one? What is that as a exponential form? X to the 3/4, right? Index, denominator. Pretty easy stuff. Good. Let's see what's next. I forget. Okay, properties. These properties are the same properties we did at the beginning, right? But now the difference is the exponents we're dealing with will be fractions. But the properties, which are in these two columns here, are the same. Well, it's actually 6 properties, and when we did it on page 360, there was 7. What's the one property that they don't have here? Anybody spot the property that's missing? Say again? Yeah, the raising to the 0 power. What is anything to the 0 power? 1. But of course, that would not be pertinent to rational exponents because 0 is not a fraction. So they didn't have that one, but the other 6 are here. Right? When you multiply, you simplify by adding the exponents. Right? When you divide, you simplify by subtracting the exponents. Right? When you raise a power to a power, you multiply. Right? When you've got parentheses and then an exponent, hey, Mark, stop it. Okay? When you have the power outside the parentheses, move it inside, distribute it. Whether or not it's like this as a product or a quotient, it goes inside. All right, and what's the other one? Okay, what do you do when you have a negative exponent? You flip it to the other side. Now, all of their examples, they're showing you an example where they did this with fractions. So you don't really need to copy these, but you should have them. They're the same. We're going to do some examples now. Now, we have to simplify this as radicals. I mean, that looks like it's impossible. Convert it to exponentials and then see what it looks like. What is the numerator here as an exponential? X to the 3/4. What is the denominator as an exponential? X to the 2/8, right? But that is X to the 3/4 over X to the 1/4, right? Okay, now by the properties of exponents, how do you simplify when you divide? The base is the same, X and X. You subtract, right? So this becomes X to the 3/4 minus 1/4, which is X to the 2/4, which is X to the 1/2. Okay, now since we started with a radical form, we should convert it back. So what is that? It's the square root of X. So that mess right there in the end simplifies as the square root of x. Right? You would have never thought it. Right? By converting to the rational exponents, it becomes more clear. At least what you should do next becomes a little more clear. I think I got one more like that. Okay. Okay, let's do the next one. Right? Looking at these as radicals, it's not clear how to proceed. Turning them into exponential notation. Guys, we playing now? I got two words for you. What do you think they are? Grow up? Sitting over playing patty cake or something in the middle of class? Okay. How do I rewrite the first one? 3 to the 1/2. Okay. How do I rewrite the second? 3 to the 1/4. Right? How do you simplify when you're multiplying? You add, right? That's an add. 3 to the 1/2 plus 1/4. Which again, I mean, if you add fractions, you need a common denominator. So we're kind of like we're going backwards on the problem before, right? So we're going to turn this 1/2 into a 2/4. So that's 2/4 plus 1/4, 3 to the 3/4. And how do I rewrite that as a radical? It is what's the index? The 4th root of 3 to the 3rd. Right? If all you were being asked is to like convert from one to the other, I would just leave it there. It's fine. Because these fractions don't have a common denominator. We need a common denominator. Now, you can remember, I mean, at this point, you should know how to do fractions easily. I know you don't. Most of you don't. So you do know how to put that in the calculator. Just put it in the calculator and then turn it math enter back into a fraction. Okay, how about this one here? What's the numerator as a exponential form? X to the 3/2, right? And the denominator? X to the 2/3. Okay, again, how do we simplify when we're dividing? What's the property of exponents? Subtract. X to the 3/2 minus 2/3. Right, what would be the common denominator? 6. Right, so this is X to the 9/6 minus, oops, that was wrong. Okay, 2/3 would be 4/6. So that is X to the 5/6. And then rewrite it as a radical. Rewrite it as a radical. The 6th root of X to the 5th, or remember, you can do this and it's the same thing. Whether the power is inside or outside, it's still the same. Okay, before we get to that, I'm just going to digress just a little. Just for you guys. I wouldn't do that for anybody else. No, in 2 years, when many of you start calculus, what you'll see is that you spend about half of your time doing what's called a derivative, the other half doing what's called an integral. And the most basic kind of taking of a derivative is with polynomials, and it works something like this, right? Let's say I have x to the third. My polynomial is x to the third. Then the derivative, which I write like this, is you take that 3 and you move it to the front, and then you subtract 1 from the exponent. Okay, it's a fairly basic procedure to do that. If you have a polynomial with many terms, you would just do that same process for every term. That's the derivative. Okay, now if your function was something like the square root of x with a radical in it, you can still use that property, that rule for the derivative, but first it needs to be exponential form, right? I would have to write it like this, x to the 1/2. And then using that same property, I would take the exponent and I would move it to the front, and then I would subtract 1 from the exponent. What's 1/2 minus 1? Negative 1/2. Right, so this is 1 over 2 times the square root of x. So that's probably the one place that you are likely to see exponential, or the, what do you call, rational exponents used. And you have to use them that way to simplify those kinds of problems. Okay, now when it comes to simplifying expressions, right, they deal with it in two different ways here. The first is we just deal with the number. Radical expressions might have a number involved, and they might have some variables involved, and we're going to deal with them in two different ways. When it's just a number, then here's a couple of different processes that they're showing, and it all involves properties of exponents. Right? 16 to the negative 2.5 equals 16 to the negative 5/2. What did they do there? They just turned it into a fraction, right? Okay, now they made this 16 into 2 to the 4th, and then how did they go from this line to this line? Now they're writing 2 to the 4th, 2 to the 4 times negative 5/2. What are they doing? That means they're raising a power to a power, so they're showing multiplication, right? And so 4 times negative 5/2 is negative 10, right? Now they go from here to here. It was 2 to the negative 10. Now it's 1 over 2 to the 10th, right? There's the getting rid of the negative exponent. And then 2 to the 10th, you put in the calculator, it's 1024, if you have to put it in the calculator. Now, it's almost the same. Over here, they convert it to the fraction. Then they use the negative to flip it at that point, right? And now they're going to write this as the square root of 16 because the denominator was 2, and they're raising all that to the 5th power. Okay, what's the square root of 16? 4. So from here to here, they simplify that, and then they raise it to the 5th power, which is 1024. Okay. The method 3 is put it in the calculator. I mean, I wouldn't be, so caught up on trying to go through it longhand when the calculator do that part. You'll get to use your properties of exponents when you get to the variables. Those you can't put in the calculator, but these you definitely can. I mean, in this one here, if I put in the 16 to the negative 2.5, and I hit enter, and then what do I have to do? Math, enter, enter. 1 over 1024. So the number part should not be an issue. Now, if you're at home and you don't have a graph and calculator, then do it a long way. I mean, you should have time to do this in class today and be done with it. Right, so try to do that. Try to do those two with your calculator. I'll give you 20 seconds. How's that? 3 to the negative 3/5. 32 to the negative 3/5. Time's up. Come on. I mean, the only thing you can do here is like fat finger the numbers you're pushing. What's the first one? Okay, that is 1/8. Okay, and this one is 8. Right, that's just putting it in the calculator. Okay, I mean, before calculators, quiet please. The way that, I mean, most of these numbers, they're not giving you like terribly complicated numbers. They're all like powers of 2 or 3, maybe 4 and 5, but they really don't go that high. But, you know, understanding what this means, what I would have done if I had that same problem is I would have just said, oh, that's the 5th root of 32. Well, that's 2. And to the 3rd power, 8. Right? The 5th root of 32, 2, raised to the 3rd, 8. Done. Just like this one here, I would have said that's the 4th root of 16, 2, raised to the 3rd power, 8. But I mean, you got to be familiar with those things. I think we used to do a lot more of, you know, like having to deal with all the powers of 2, you know, 16, 32, 64, 120. I mean, we saw those all the time. I mean, even if you didn't remember, like 256, which one is that? It would take you a couple seconds to figure out how many times you multiplied times 2. Okay, now when it comes to the expressions, now we're going to have a number part and we're going to have a variable part. Now, by the properties of exponents, what am I going to do with that raised to the negative 3/4 outside parentheses? I'm going to bring it inside. It'll be 16 to the negative 3/4, y to the negative 8 to the negative 3/4. Right? Remember, that's the, when you've got a power outside parentheses, we think of it like distributing. Right? That's 16 to the negative 3/4, y to the negative 8 to the negative 3/4. Okay, again, this first part, you are free to put it in the calculator if you want. What is it? Again, if I just take, for myself, I would say the 4th root of 16 is 2. 2 to the 3rd is 8. And because it's a negative, it'll be 1/8. Again, you can get that out of the calculator. Now, what did we do to simplify this? Raising a power to a power. It's a multiply, right? Raising a power to a power, that's where you multiply. So what is negative 8 times negative 3/4? It's 6, right? Y to the 6. So 1/8 y to the 6. Probably if you look in like the answer, if it was in the back of the book for a homework problem, they would write y to the 6 divided by 8. Same thing. Okay. I think I have one more example. One more for you to do, and then we're done. So try to do that one. So what do we get? What's that? 2x to the 5th power, incorrect. So you're saying it's 1 over 2 x to the 5th? Like that? Not that. 1 over 2 x to the 5th. Is that right? Right. Because remember, you're going to have to take this 1/3 in both. That'll be 8 to the negative 1/3 x to the 15th to the negative 1/3. Right. 8 to the negative 1/3, again, it's the cube root of 8, but it flips to the denominator. That's 1/2. And x to the 15th to the negative 1/3, if you multiply, that's x to the negative 5th. So then you flip that to the other side, and you get that. Easy. Okay. So that's what we did. I mean, we did more than that. That's the SOL. All I ever show you here is what the SOLs say, because that's what they want to see when they walk in.